There are basically two ways that you can enter data into a program. One is to allow the user to enter the data through a series of prompts. That is, using a cout statement, such as you see here, that prompts the user to enter a value, and then follow that with a cin statement, which will accept the data from the keyboard. The operator you use with the cin statement, the extraction operator, which is the double right braces, tells the C compiler to stop reading characters from the keyboard as soon as the user enters the enter key or types a character that is inappropriate for the variable's data type. For example, I have a short variable for num1. So if I run this already compiled program and enter a value such as 5, it returns the value of the variable. If I run the program once again and enter a value which is beyond the range of a short integer, such as 55,000, you'll notice the value of the variable is 32,767, which is the maximum number for this type of variable. Likewise, running the program one more time, and I enter 5,000 for 5,000, you'll notice what is stored in the variable is simply the number 5. The comma is considered an invalid character with a short integer data type, and therefore is not accepted. Everything after the comma is ignored. An alternative to allowing the user to enter data is to assign data to a specific variable through an assignment statement in your code. The syntax of the assignment statement is the variable name on the left-hand side of an equal symbol, followed by an expression or a value. Allow me to present an example. I'll first delete our cout and cin statements and replace it with an assignment statement. Num1 equal, followed by the value that I want to assign num1, in this case 50, followed by a semicolon. Now this serves the same purpose as assigning the value 50 to num1, as if the user had entered 50 when prompted. I'll recompile the program now that I've made this change. And as you can see, no errors, no warnings. I'll go ahead and execute it. And as you can see, the program does return the value of the variable as being 50. Of course, each time I run this program, I will get the same value since I am assigning a specific value to this variable. The difference between this and a constant, however, is that num1 could take on a different value where a constant is protected. For example, if immediately after assigning the value 50 to num1, I then create a formula such as num1 plus 10, this should now yield the value of the variable num1 to be 60, since I'm assigning the value of num1 to 50, and then I'm adding 10 to it and replacing num1 with a new value, which is the old value plus 10. Let's recompile this program to verify the results. Correct compile, and then as you can see, the value of the variable is now 60. It is important to remember that a variable can store only one item of data at any one time. When you use an assignment statement to assign another item to the variable, the new data replaces the existing data, as in my example here. To complete this example, a better programming technique would be to initially give num1 the value of 0. Therefore, initializing the variable at the same time it is being declared. And then num1 equals 50 replaces that 0 with a 50, and then the assignment statement adding 10 to num1 then creates num1 to be equaling to 60. Of course, whether you use assignment statements or prompt the user using cout and cin statements, the rules of variables still need to be followed, and the syntax needs to be adhered to. This concludes Chapter 2, and in the next chapter, I'll be looking at the string data type and some other functions associated with special data types and equations.